Today, we're going to talk about one of the great instruments of science, the Voyager spacecraft. The Voyager 1 spacecraft, launched by NASA in 1977, has been traveling through space for more than 4 decades, covering an incredible distance that has taken it far beyond our solar system. Initially designed for a mission expected to last only 5 years, Voyager 1 has far surpassed all expectations, continuing to function and send valuable data back to Earth. Recently, this remarkable spacecraft made a groundbreaking announcement that has captured the attention of the scientific community and space enthusiasts alike. During its ongoing trajectory through the vast expanse of space, Voyager 1 detected something extraordinary: the presence of 300 unknown objects passing through space. This discovery has completely upended our understanding of the cosmos, as these objects have been identified as plasmas, remnants of giant star explosions that occurred millions of years ago. The significance of this discovery cannot be overstated. It opens up new avenues of research and raises fundamental questions about the nature of these objects and their origins. Are they remnants of ancient celestial bodies that have drifted across the universe? Could they be relics of distant star systems? Or do they represent a previously unknown phenomenon that defies our current understanding of space? These questions have intrigued scientists around the world, prompting further investigation into the mysteries of interstellar space. For years, our ability to analyze data was confined to the limits of our solar system, but thanks to the innovative technology aboard Voyager 1, we now have the capability to explore beyond these boundaries. In August 2012, Voyager 1 officially crossed the heliopause, the boundary that marks the edge of our solar system, and entered interstellar space, becoming the first human-made object to do so. This milestone was a monumental achievement, but it was not without its challenges. As Voyager 1 moved farther away from the Sun, the amount of sunlight available to power its instruments and systems diminished significantly. The spacecraft relies on 3 radioisotope thermoelectric generators, RTGs, for power, which convert the heat produced by the natural decay of plutonium-238 into electricity. However, as the heat output of these RTGs has decreased over time, the available power has also declined, impacting the operation of various onboard systems, including scientific instruments, data transmission, and communications. To conserve energy, NASA engineers have had to make difficult decisions, deactivating non-essential systems and placing some instruments in a dormant state. Despite these efforts, it is clear that Voyager 1 will not be able to operate indefinitely. Nevertheless, even in its current state, it remains an invaluable asset to humanity's exploration of the cosmos. One of the greatest challenges faced by the Voyager 1 mission is the immense distance between the spacecraft and Earth, which presents significant obstacles to maintaining effective communication. As Voyager 1 ventures deeper into interstellar space, its signal strength is weakened, making it increasingly difficult to transmit and receive data. The spacecraft is now so far away that it takes more than 21 hours for a signal to travel from Voyager to Earth. This weak signal is further complicated by interference from background cosmic noise, which can obscure the data being sent. Additionally, the transition from the heliosphere, where the spacecraft was relatively close to the Sun and experienced higher temperatures, to the frigid environment of interstellar space has exposed Voyager 1 to drastically different thermal conditions. These temperature changes have the potential to affect the spacecraft's sensitive instruments, posing another challenge for mission engineers. Despite these difficulties, Voyager 1 has continued to perform its mission admirably, and it recently made a fascinating discovery that has added a new layer of intrigue to its journey. Amid the data stream sent back to Earth, Voyager 1 detected an anomaly: the presence of 300 unknown objects traveling through interstellar space. This discovery has left scientists puzzled and excited, as it challenges many of our preconceived notions about the universe. Could these objects be the remnants of ancient celestial bodies, drifting remnants of long-gone star systems, or perhaps something entirely new and unknown? The discovery raises more questions than it answers, but it is clear that these objects are not like anything we have encountered before. The information transmitted by Voyager 1 is usually straightforward and easy to decipher, but in this case, the data was encrypted, adding another layer of mystery to the discovery. This encryption raises several intriguing questions. Why was the data encrypted? And what does it mean for our understanding of the objects detected by Voyager 1? Strangely enough, despite the unusual nature of the data, Voyager 1 appeared to be functioning smoothly. Its communication link with Earth remained intact, and the signal was strong enough to allow valuable information to reach NASA without much trouble. Interestingly, none of the spacecraft's protection systems were activated, which indicates that there was no immediate threat. This rules out the possibility of an attack or other hostile action, leaving scientists to speculate on what could be causing the telemetry data to appear scrambled or inaccurate. One theory is that the interference could be the result of cosmic phenomena, such as radiation or high-energy particles. Alternatively, it is possible that we are dealing with a completely unknown phenomenon that defies our current understanding of space. The only way to obtain certainty was to conduct a meticulous analysis of a wide range of possibilities. The NASA research team set to work, thoroughly analyzing the spacecraft systems and considering all potential factors that could be contributing to the anomaly. They took into account the impact of cosmic radiation on Voyager 1's electronics, as well as the possibility that temperature fluctuations could be affecting its sensitive instruments. There was also a chance that something had happened just before Voyager 1 entered the heliosphere, causing natural changes in its path that might have led to data transmission problems. However, Voyager 1 was not in the area where these natural changes were concentrated, so this explanation did not seem to fit. The team also explored the complexities of Voyager 1's communication systems, investigating the possibility of distortions caused by cosmic noise, interference, or even subtle changes in the spacecraft's trajectory. The search for answers led to a meticulous analysis of all these potential factors. Although it might sound like a simple task of checking boxes on a list, the reality was that there was a lot of work to be done. The investigation was not instantaneous. It dragged on for weeks as the team advanced data processing techniques, developed innovative algorithms, and ran simulations of various scenarios to identify the root cause of the unusual anomalies. After months of receiving encrypted data from the spacecraft, scientists and engineers finally made a breakthrough. They were able to restore clarity and reliability to the information coming from the far reaches of interstellar space. The cause of the problem was traced back to Voyager 1's attitude articulation and control system, ACS, specifically an onboard computer that was supposed to be inactive. To the team's surprise, it was discovered that the ACS had begun using this computer, despite it not being operational for years. This unexpected development led to the corruption of the transmitted data, but fortunately, the rest of the spacecraft remained operational and continued to collect valuable data. To resolve the issue, engineers acted quickly and sent a command to Voyager 1, instructing the ACS system to switch to the correct computer for transmitting telemetry data. Although the solution was considered low risk, it required a great deal of patience due to the significant delay caused by the distance between Earth and Voyager 1, with radio signals taking nearly 22 hours to travel back and forth. The troubleshooting process demanded careful coordination and precision. There was also another challenge. Voyager 1 was built decades ago in the 1970s and has been performing admirably ever since. However, finding a solution to this modern problem required the team to review several old manuals from that era. After careful examination, they found a simple solution to the problem by restoring the system responsible for data transmission. In this way, they managed to fix the issue without affecting any other part of the spacecraft. The experience and dedication of the engineering team played a crucial role in restoring clarity to Voyager 1's communications. Their efforts underscored the importance of leveraging past knowledge and combining it with current technology to meet the challenges of space exploration. Engineers suspect that the deviation in the use of a non-operational computer on Voyager 1 was triggered by a faulty command received from another onboard system. This hypothesis suggests an underlying problem in the spacecraft's intricate computer network. Despite this incident, mission managers remain cautiously optimistic, emphasizing that it does not pose a threat to the long-term well-being of Voyager 1. The spacecraft corrected the error and continued with its mission right after the correct computers came back online. As we continue to receive data from Voyager 1, its journey through interstellar space reminds us of the incredible achievements of human ingenuity and the endless possibilities that await us in the cosmos. The challenges faced by the spacecraft, from dwindling power supplies to communication difficulties, highlight the complexities of space exploration but they also demonstrate the resilience and determination of the teams working to keep Voyager 1 operational. As the spacecraft continues its mission, we can only imagine what new discoveries it will make in the future. Thank you very much for watching the video. Remember to like and subscribe, and I'll see you in the next one.